All right, welcome back for 5.2. We are once again in Unit 5, Statistical Reasoning. 5.2 is going to deal with frequency tables, histograms, and frequency polygons. Now you don't need to write this down, but we'll just read through it together. It says large sets of data can be overwhelming and difficult to interpret. By organizing this data, it can help us see what the data is telling us. And how could we organize the data to make it more visual? So there's going to be a lot of questions in this one that you're not going to want to write down, as there's far too much information on the screen. But it's be good to watch and just pay attention to so you can recreate it for your assignments. As you can see in example 1 here, it says the following data represents the water flow rates of the Red River in Manitoba. And this has got how the water has flowed through the river from 1950 all the way up to 1999. Okay. The ones marked in pink are the those are the years there were floods. Okay. So there's a lot of data on here. So to try to do things like find the mode or the median, the range, that's not really going to work very well with something like this. We need a better way to interpret it. So what we are going to do is we're going to make what's called a frequency distribution table, which is a set of intervals, usually of equal width, into which raw data is organized. So here's what it would look like. The first thing you have to do is determine the size of your intervals. So you calculate the range. So the range, again, is the largest number minus the smallest. So the largest number is 4587 minus the smallest one is, I believe, 159 is the smallest one. 4587 minus 159 is about 4,428 is the range. And then it says step 2 is to divide the range by the number of the amount of intervals you want. Okay. So whether you want 10 intervals on your table or you want 5 intervals, it's up to you. Okay. In this one, it says try to have between 5 and 12. We're going to take intervals of, we're going to take about 9 intervals here. So let's just divide it by 9, because that will give us an interval size of about 500. Okay. 4428 divided by 9 is 492. So we're going to have our interval size be approximately 500. And you'll see that on the next page here. Okay. So this is what a frequency distribution table looks like right over here. You can see that the values have been organized in intervals of 500, right? From 0 to 500, 500 to 1,000, 1,000 to 1,500, all the way up to 4,500 to 5,000. Okay. So what you need to do is, once you have your interval sheet, your interval size, tally how many of each of your data fall into the interval. So I'll do a couple for you, and then I'll click ahead to the answers. So for example, 3,058, that occurs between 3,000 and 3,058, or 3,500. So we put a tick down there. 1,065 would go here. 1,008 go there as well. 357 is down there. 524 is there. 1521 right there. 1974. You can see this is a pretty easy process. A little time consuming, but ultimately not the most difficult thing you've ever done. Okay. Now, if we click ahead, we've got the answers all filled in. And this is what it looks like. The tally is how many occurred right in there, and the frequency is the once you've added up all the numbers in the tally. So there was 6 years where the flow rate was between 0 and 500. There was 11 years where it was between 500 and 1,000. There was 9 years where it was between 1,000 and 1,500, all the way through. Now the question asked you, if the question asked you when were the severe floods, Well, the severe floods probably occurred when the water flow rate was the highest, right? So if I told you that there were 9 floods in total, okay, what would you guess would be the minimum flow rate resulting in a flood? Well, if we're looking for when there was 9 floods, I look down here where the flow rate was the highest, and I'm kind of looking to where I got to the number 9. Well, that's 1, 3 is 4, 5, and 10. So it looks like if the water flow is anything greater than 2,000, that seems to be when the floods occur. Because if they tell us there's 9 floods in total, and we can see these are the 9 times that the water flow was the highest, that's probably what led to the floods. Now, if it's a confusing question because you don't know about river flow rates and about how that results in floods, that's fine. Not all the questions will be about that, but that's just the way to interpret the data. If they tell you there's 9, I'm just looking for when my numbers basically add up to 9, and I know that's what leads to the floods. Now, the next thing you can do is something like this. You can make something more visual. So once you have a frequency distribution, you can use that to create a histogram or a frequency polygon to represent the data in a more visual way. So I'm going to show you what those would look like. This would be something you could have to make on an assignment or a test, but the graphs would be given to you. So a histogram is the graph of frequency distribution in which the equal intervals are marked on a horizontal axis and the frequencies associated with these intervals are indicated by the height of the rectangles drawn for these intervals. Now that sounds confusing. The actual picture of it is not. A histogram kind of looks like a bar graph. Well, it might be something you might associate it with, okay? I filled in the numbers. Our frequency sort of varies between 0 all the way up to 14. So I've got 0 to 14 here, and the flow rate goes from about 0 up to 5,000. So I've got that labeled on the bottom. So here's what your table would look like. From 0 to 500, the frequency, that happens 6 times, right? So I would go to, for 0 to 500, I would draw a little line like that, hopefully a little straighter than my line was, okay? There were 6 times it happened between 0 and 500, okay? Between 500 and 1,000, the frequency was 11. So I'd go up to 11 for 500 to 1,000. Try to clean this up a little bit. Between 1,000 and 1,500 happened 9 times. So that's between 10 and 8. So 1,500 to 2,000 happened 14 times. That's up here. Okay. 2,000 to 2,500 happened 5 times. So 5 is right here. 2,500 to 3,000 happened once. 3,000 to 3,500 was 3 times. 3,500 to 4,000 and 4,000 to 4,500 is 0, so they'll just stay down there as 0. And there was 1 that occurred between 4,500 and 5,000. Okay, so mine's a little bit messy, but this is a more visual way to interpret what was on our frequency distribution table. Okay, this is what's called a histogram, and again, if you want to call it a bar graph, that's fine too. Okay, now a frequency polygon is the graph of a frequency distribution produced by joining the midpoints of the intervals using straight lines. So here's what this would look like. Frequency polygon, instead of making the bar graphs, you are going to join the midpoints of the intervals using straight lines. So the midpoint of the interval of 0 to 500 is 250. So 250 happened 6 times. So I put a dot there. 750 is the midpoint of 500 and 1,000. That happened 11 times. 1,000 to 1,500, the midpoint's 1,250. That's 9 times. And I'll just fill in a few more here. 2,250 is 5 times. 2,750 is once. 3,250 is 3 times. These ones are 0. We'll leave them down there. And the midpoint of 4,500 to 5,000 is 4,750, and that happens 1 time. And now what we can do is we can connect our dots. Okay? And that's what our frequency polygon looks like. So you can be asked to make a histogram, which is the bar graph, okay? Or another way to interpret the same set of data is to make a frequency polygon, which is just where you're going to put the dots at the middle of the intervals and then connect the dots, okay? Now, example 2, they're going to give us the histograms, and we have to interpret the data. So it says the following histograms represent the frequency of earthquakes based on their magnitude in Canada. Which year do you think would have had the most damage from earthquakes? This is the question they want us to answer. Which year would have the most damage from earthquakes? Okay, so they've given us a table so we can understand the Richter scale. Earthquakes that are less than 3 on the Richter scale, you don't even feel them. 3 to 3.9 feels like a passing truck, but there's no damage. At 4, everyone will feel them and things will start to move. 5, considerable damage to weak buildings. 6 makes it difficult to stand, partial collapse of ordinary buildings. 7 to 7.9 means the loss of life and destruction of ordinary buildings. And anything over than 7.9 is widespread loss of destruction and life. So our question is, which year do you think had the most damage from earthquakes? Okay. So here's 5 years that they gave us, okay? And it's our job to interpret the data. So the first thing that might jump out to you is 2005, because 2005's got this number right here, it goes up the highest. But these are, that means here, there were 20 that were between 3 and 4. So let's go back to 3 and 4 for a minute. Between 3 to 3.9 feels like a passing truck with no damage. So something with no damage is not going to be, that's not going to be the year that affects it. They had a lot of them there, but they didn't cause any damage, okay? So what we're looking for is we're looking for something that's got a lot more that are higher up on the graph, right? More to the right. For example, 2008. 2008 has got 16 that occurred between 4 and 5, which does lead to some damage, as well as a few more between 5 and 6, and 6 and 7. So this would be the year that would have caused the most damage, because it had the most sort of after 4. 2009 is close, but 2009 only goes up to 14 and then down to 7. Here we've got 16, then 5, and then 4. So 2008 would be the proper answer. There's a little bit of wiggle room on interpreting questions like this, where if you had gone to 2009 and you could explain it, I could mark both of them correct, okay? Another way they could give you frequency polygons, right? So the red is 2008, and the blue was 2009. And with the frequency polygon, you can see that 2008 had the higher amount of damage on the Richter scale. So you can see how 2008 beats 2009. So 2008 would be the worst year. Okay, so it's just a different way to interpret the same data. So once again, large sets of data can be difficult to interpret. Things such as frequency polygons, frequency distributions as tables, histograms, or polygons can be helpful ways to interpret your data. Okay? Your assignment for this, ignore that. Your assignment is on page 113 of your workbook. Pages 113 to 115. And that'll give you a chance to practice some of this stuff, okay? You can ignore these. Thank you. Have a good day.